Okay, so a rate of change is set up. Typically, we look at it like a fraction. And so you're looking at something, some number happening per some other thing. So you're comparing two different numbers to each other, how quickly they're changing, basically. And the way we always look at that in algebra is as the change in y over the change in x. It's really this symbol, this little triangle called the delta, and it means change. So it means the change in y over the change in x. So when you're looking at a problem like the one that I have over here on the left side of the screen, so this is IXL code from last week, PLA. So it's basically asking you what the rate of change is from Tuesday to Wednesday. And so really that's all you're paying attention to is what happened on Tuesday when there was 62 versus Wednesday when there was 100, right? So the change in y is 62 to 100. So that goes up 38 plus 38. And then the change in x, so my days, is 1 day. So it goes up by 1 day. So really you're saying the change in y over the change in x equals 38 over 1. So when you add units to that, you're saying y, right? So y is on top. So this is 38 loaves in my y's over here, right? And then per day. So you're saying 38 loaves per day. So you're only paying attention to the two that they give you. So let's jump up a level. And if I look at this one, it's saying from Wednesday to Saturday. So Wednesday was 18 minutes and Saturday was 23 minutes, right? So these are days, and those are minutes. So if I'm looking at that rate of change, so the change in y over the change in x, I'm really looking at the change in minutes over the change in days, which is 18 to 23 here, right? So that's plus 5. And then here, Wednesday, so Thursday, Friday, Saturday, so plus 3 days. So 5. So 5 minutes every 3 days. Okay, so that's IXL code PLA. How about if we look at from a graph? So the graph is kind of the same idea. We just don't have a table in front of us. We have to look at the picture and decide what the table is. So this is asking us from 2014. Sorry, this is IXL code from last week. BNH. So 2014, looks like if I look at my graph, 2014 was at 65. And 2016 was also at 65. So if I think again about the change in y over the change in x, right? That's really the change in students per year. Right? So if I'm really looking, this doesn't change at all. And this changes by 2. But in this situation, it's 0 over 2, which means it's changing by 0 students per year, according to those two data points. Although if we look at the rest of this, you can see that there is actually some changes happening throughout, but if you're just looking at 2014 and 16. Same idea here. So 2015, I'd be comparing 60, it looks like, to 52. So it's a change in 8 over the course of 3 years, 8 over 3. So hopefully that seems pretty straightforward as far as the rate of change. That leads directly into what we were doing with today with slope. So now it's asking you to find the slope, which really is finding the rate of change between 2 points, except this is in a linear situation. Slope of a linear. And this is IXL code 7C, which is actually this week's work. But if I'm looking for slope, I just have to find 2 points. So if I'm looking at a table of X's and Y's from this graph, I can choose any 2 points that are on here. So it looks like the first one I can see visibly is 0, 30. And then, so that's here. And if I keep tracing this up, it looks like this is a good one, right? 50, 50. And the next one on this one, that would be 170. So I just need to do what I was doing before. I'm looking for the change in Y over the change in X. Since this is a linear equation, linear functions have constant rate of change everywhere. So no matter where you're looking on a graph, it has a constant rate of change, which a rate of change, another word for that mathematically, is slope. So it has a constant slope everywhere. What that really means is you can choose any 2 points and find the difference between them, and it'll give you the right answer. So I always tell kids to choose the easiest. If I look from 30 to 50, this is going up 20. And if I look from 0 to 50, it's going up 50. So it's the change in Y over the change in X. So 20 over 50, which reduces to 2/5. So the slope of this line is 2/5. So you do need to reduce. Two-fifths. Same idea for this next one. I would be looking for 2 points. So it looks like the first one I can see pretty clearly is 1080. And then 4090. So I don't really need to go any further than that, right? 80 to 90 is plus 10, plus 30. The change in Y over the change in X is 30 over 10, which really is 3. So my slope for this is 3. And that really relates to the last topic we did last week. I Excel code DAQ. Because when they're asking you to graph these functions, this is in slope-intercept form. And this number here is the slope. So if I'm looking at the slope as being 3, then I'm really saying it's 3 over 1. And that's that same rate of change. This is the change in Y over the change in X. So really what you're saying is since that's a 3, it's going to go up 3, and it's going to go over 1. So it's going to start at 0, 0, and then go up 3 over 1. So start here in the middle, and then go up 3 over 1. So this one, -2. So Y equals -2x. This slope equals -2, which is -2 over 1. So since it's negative, you're saying go down 2 over 1. But again, I'm starting at 0, 0. So starting at 0, 0, go down 2 over 1. So hopefully all that